Right, so this is exercise 7a, question number 5. We're going to skip past 1 through 4. We're going to do 5 and 6. It says, in a manufacturing process, the proportion P of faulty articles has been found from long experience to be 0.1. A sample of 100 articles from a new manufacturing process is tested and 8 are found to be faulty. The manufacturers wish to test at 5% level of significance whether or not there has been a reduction in the proportion of faulty articles. So we are looking at if there has been a reduction in the proportion of faulty articles. So suggest a suitable test statistic. So let X be the number of, obviously we are testing for the reduction of faulty articles, so X be the number of faulty articles. Write down two suitable hypotheses. So our initial claim or the original claim is that the faulty article, the proportion of the faulty articles is, the proportion is 0.1. So I can say my original or my null hypothesis is the probability of getting a faulty article is 10%, or we could say it is 0.1. But we want to check the claim whether there has been a reduction in the proportion. So obviously the alternate claim that we are testing for is if P is less than 10%, meaning there was a 10% chance that you could get a faulty product or a faulty article. Now the company is claiming, or the manufacturers want to check if the proportion has come down, whether it became 8% or it became 6%, we don't know. The claim is, or that we are testing to figure out if it has come down less than 10%. So explain the condition under which the null hypothesis is rejected. So in any hypothesis question, the question that we ask is, the main question that we ask ourselves is this normal? So we have to establish what is normal. Normal is 5%. So if the chance of happening, if the chance of something happening is less than the normal, then we can reject the null hypothesis. So if the null hypothesis has to be rejected, then we know that we have to say it is not normal, or the chance of something happening must be less than the normal, which is 5%. So the question is, what should be the question? What is the question that we ask? We know it has something to do with the X or the test statistic. We are looking at whether there has been a reduction in the number of faulty articles. So if you think about it, 10% is the claim. So if we are testing 100 of them, what is normal? It is normal to get 10 out of 100 as faulty, because our claim is there is a 10% chance that you would be getting faulty, 10% of them as faulty. But here we've got 8 of them. So we ask, is it normal to get 8 or less than 8 when we are testing out of 100 of them? Is it normal to get P of x less than or equal to 8. Why am I looking for less than or equal to 8? Because if I want to know, has the proportion of the faulty articles come down from 10% to maybe it could be 8%, 7%, 6%, we don't really know, but we want to know if it is true, if this is normal to get less than 8 in a test of 100 articles. So if this is less than 5%, meaning if there is less than 5% chance that they are, there is a chance that it could be 8 or less, then we could reject the null hypothesis, saying that there is evidence, and then we could accept the alternate hypothesis, saying that the percentage or the faulty article proportion has actually come down to 8% or 7% or something that is clearly less than 10. We could try the same thing with question number 6. This time we have polls showing that 55% of the voters, they support a particular political candidate. A newspaper releases information saying that the candidate avoided paying taxes. So following the release of this information, the company has asked 20 people whether they support the candidate. 7 people said they did. So the company wants to test whether the level of support has been reduced. So we are looking at, again, a reduction here. So the test statistic, we are testing for the number of people. So let X be the number of supporters of the candidate. So that is our test statistic. Our original claim is H0, the candidate has 55% of the support, meaning the chance of picking a supporter is 0.55. But the alternate claim in light of the new evidence is this percentage or the popularity has reduced. So we are claiming that it is no longer 55. It could be anything less than 55%. So as a decimal, we can say that is P is less than 0.55. So explain the condition under which the null hypothesis would be accepted. So we are checking, so we have to establish what is normal. So normal is, we are expecting 2% to be a normal chance. So if something is less than, no, if something is more than the normal percentage, we can kind of say that is okay. That is pretty normal because it's more than 2%. So you want your answer of a question to be more than 2% because 2% is where you draw the line. So the question that we ask, is this normal? So it has to be something with X. You are testing the number of supporters, and you would say, well, he got only 7 people, right? If you think 50% of 20, that is 10. So 55 would be somewhere around, let's say, 11. So if he got 11 out of 20, that was normal because the claim was he has support of 55 people. But he has got at the moment only 7 out of 20. So you're asking, well, is it normal that somebody claims they have 55% support and then they still get 7 or less? Because there's no point in me doing 7 or more, because that would mean the exact opposite. You want to test the worst case scenario. The claim is he has 55% support. So I want to check whether is it normal for somebody to claim that they have 55% support, yet when they are tested out of 20, they get less than 7 people supporting them. So if the answer for this question is somewhere around, let's say, 5%, or you get 3%, well, then you can say that's normal. If it is pretty normal that he got only 7 out of 20, then we can say, well, it is pretty normal. We can accept the original claim. What is the original claim? that he has 55% of the support. Now, if you're still confused about how to frame this question, one easy correlation that you can see is in the alternate hypothesis, if p is less than 0.5, you can choose the same symbol that would be less than or equal to 7 rather than going greater than 7. If p was, let's say, greater than 0.1, then I would have chosen the same thing here, which is greater than or equal to 8. So this is if you're finding it difficult to figure out what is happening there, you could just follow that hack. Whatever is the now alternate hypothesis, just follow the same inequality sign, which is less than. You please don't go for a proper less than. This would be a less than or equal to. I'm just trying to hint you towards, should it be less than or equal to or greater than or equal to.